This video describes the Late Posterior Component ERP, which is associated with recognition memory. This video follows up a previous video where I described both the FN400 and the LPC and evidence that they are different and also associated with recognition. But we're going to do a little bit deeper dive into the LPC in this video. Okay, just in case you missed the previous video, first I want to define very quickly what an ERP is. It stands for Event-Related Potential, and essentially we record the electroencephalogram, EEG, by recording from a number of electrodes across the scalp. So here you can see EEG, and time is the x-axis, voltage is the y-axis, and the lines represent activity on an individual electrode. We time lock the EEG to an event, like the presentation of a word or a picture, and then we average the EEG to reveal a signal. That signal is called the ERP. In research papers that present ERP data, even though recordings are taken from a number of electrodes across the scalp, they'll often plot representative electrodes. Like here you see P3 is presented in this research paper, and you can have x-axis is time, y-axis is voltage, and you see this particular ERP called the LPC is defined as 500 to 800 milliseconds. And for memory research, a lot of times we take the average activity across this interval and we compare it across conditions. So it would be the average activity for the hits compared to the average activity for the new or correct rejections. And then a lot of times we plot that difference, so we subtract the difference across the scalp in these scalp maps. So positive would be a redder color, so you can see the distribution of this particular ERP component across the scalp. Because the FN400 and LPC are related to recognition, I want to quickly talk about the basics of recognition memory. So recognition is seeing an item, and in the laboratory could be things that the experimenter presented to you, and then you're seeing them at test with a mixture of some new items, and you have to determine whether it's old, whether you previously encountered that item, or whether it's new. We can also have recognition memory in the real world, of course, if we see familiar people, objects, etc. Now, recognition can be supported by psychological concepts called familiarity, recollection, or a mix of both of those. Familiarity is a sense of oldness in the absence of remembering any specific details. And recollection is when you remember specific details of the original encounter. Like in the laboratory, we have people report on some of the contextual features that happened or that were associated with that item. We can also manipulate the degree to which you have familiarity-based or recollection-based recognition by changing the encoding processes. So this just refers to the processes that are happening when we first encounter the information, and they create the memory trace. And we could have weak encoding, where you're thinking about sort of the superficial details. In this case, you would have more familiarity-based recognition, or you could have strong encoding, where more information is bound in memory, and you have more recollection-based recognition. And just some of the ERP characteristics quickly. It's the FN400, so it happens right about 400 milliseconds. The time window that's typically used is 300 to 500 milliseconds, although this can vary a little bit. And it's called an FN because it's a mid-frontal. As you can sort of see, the distribution here is mid-frontal. And it's a negativity, meaning the negativity for unfamiliar items. So familiar items are going to have a more positive ERP. Unfamiliar items have a less positive or more negative ERP during this time window. Now, the FN400 has been associated with familiarity. I went into the evidence for that association in the previous video. The LPC, known as a late posterior component or the parietal old new effect, happens a little bit later, 500 to 800 milliseconds. Again, studied items are more positive than unstudied items. And this ERP component has a parietal distribution if it's words, can be a little bit more widespread if it's pictures or actions. And this ERP component is associated with recollection. So I mentioned in the previous slide that encoding can create recognition that is either more familiarity-based or more recollection-based. So if you think of these two concepts, familiarity and recollection, as two different memory signals, they could differ in their strength, right? So in this slide, I'm representing the memory signals, familiarity and recollection, by two different light bulbs. And when we have weak encoding, we're going to have more familiarity and less recollection. So this bulb is brighter than this bulb. And when you do that, and you look at the ERPs, you can have a situation where you have just the FN400 and no LPC. Now, similarly, you could have really strong encoding, and in that case, you would have a lot of recollection and less familiarity. And what can happen is you can have no FN400 and then a strong LPC. That happens in some studies. And in other cases, you have sort of a mix of familiarity and recollection, in which case you have both the FN400 or the LPC. So all of these conditions are possible, just depends on the individual stimuli, the encoding, all of those kinds of characteristics. So let's consider some of the evidence that is associating recollection and the LPC as we dive a little bit deeper. So this begins in early 90s with studies that were sort of linking recognition, this ERP with recognition, and one such study used R and K judgments. So R and K judgments are remember no judgments, and subjects are instructed if they can remember a particular detail, recollect a detail of the encoding episode, like the speaker's voice, for example, they would use the R to indicate that they've recollected that item. Otherwise, if they know the item is old, but they just know it's old, they would use the K judgment. And so this has been used to separate experiences of familiarity from experiences of recollection. And when you do that, you see the FN400 here is present for both R and K judgments, but it's greater for R judgments than it is for K judgments, suggesting that the LPC is related to recollection. There's many such studies like this. Wilding and Rugg also did a more objective measure separating recollection and familiarity. And what they did is had two lists of words, male or female voice, and they asked people to report not only whether it was old or new, but which voice said it. And as you can see over here, the first hit indicator tells whether or not the subject got the item right in terms of the old, new, or recognition judgment. The second one refers to whether or not they got the source correct. So in this case, they got the source correct. In this case, they did not get the source correct. And what you see here is you see a greater LPC for accurate judgments, accurate source recollections, than inaccurate source recollections. And so on the basis of this idea is that if you can remember the source, you can recollect a particular detail, and therefore the LPC is associated with recollection. We have to be careful about simply using source judgments as a measure of recollection, because it's a little bit more complicated than that. What we did in this study is we had people study words in a male or female voice, and in one condition they used a self-focusing condition. They were asked, do you like the word? So they were relating it to themselves. And in another condition, they were focused on the speaker. Does the speaker like the word? And the reason we did this is evidence had indicated that self and other focus changed source monitoring ability or ability to identify the source of the information. So one of the things we found in terms of the behavioral outcomes is that self-focus had better recognition overall. They remembered more of the items, but other focus, they remembered more of who said it. Now, if you look at the ERPs for this, in particular the other focus, it looks a lot like the Wilding and Rugg paper that I just sort of showed you, such that hits here are the red line, so these are old items called old, and the source is correct. Confusions are old items were called old, but they were confused with the other source here. And so what you see here is you see an LPC for hits, but no LPC for the confusions, just like the Wilding and Rugg paper. However, in the self-focus condition, you notice that we got an LPC for both hits and confusions. So what's going on there? Well, the self-focus encoding creates a lot more recollection, and so what was happening, even in these conditions where they didn't get the speaker right, they were recollecting information that didn't help them make the source judgment that we asked for, which was the speaker's voice. So you have to be careful. The source judgment gets at information that is diagnostic for that particular judgment and not recollection in general. We could be recollecting details that have nothing to do with the experimental situation. Another thing to keep in mind is that you can also base your source judgment on the absence of information. So what we did here in this study is there were imagined items or imagined words in particular across two different testing situations. In one testing situation, these imagined items were paired with words that were read, and in this case, the imagined items elicited the LPC. However, in the other condition, imagined items were paired with words that were generated. So the research subjects created their own words. And in this case, there was no LPC. So here you can see the difference in this panel down here across the two tests. And so the way we attributed this is, so now keep in mind, they're making accurate source judgments, but there was no LPC in this particular situation. So the interpretation of this is that the source judgment was actually based on the absence of particular details. In this case, the absence of generated details in those imagined items. So we can make source judgments based on the absence of information. We can also make source judgments based on familiarity as well. So we have to be careful with simply using source as a measure of recollection. So one related issue, I want to talk about the LPC recollection in the hippocampus. So recollection has been strongly associated with the activation of the hippocampus and left parietal cortex in particular. So here you see the hippocampus across many studies, left parietal cortex, and here you see the left parietal cortex in this Vilberg and Rugg paper. Now, one study, Rick Adante and colleagues, what they did is they tested patients that had hippocampal damage and healthy controls. And you can see that the controls have the LPC, but the hippocampal patients had no LPC, and of course they had impaired recollection because, as we know, the hippocampus makes it difficult to perform episodic memory tests. Now, the hippocampus probably doesn't necessarily generate the LPC because there's another study like Ali et al. What they did is they measured ERPs in patients who had damage to the parietal cortex, so their hippocampus was intact. Importantly, their behavioral performance was intact too, so they didn't show any memory deficits in terms of behavioral measures compared to the control patients. However, there was no LPC, so this suggests that the hippocampus is necessary but not sufficient to produce the LPC, and that the hippocampus probably sends signals to another area like the parietal cortex during recollection. Interestingly, the patients in this reported a diminished sense that the event was personally experienced. So this is some evidence that links parietal cortex with vividness, parietal cortex LPC with vividness, or what Endel Tolving called mental time travel. So is there any evidence for this? In fact, there is evidence for this. So we looked at source correct judgments, and then we had people report on them by making an R judgment when the recollection was vivid, or a K judgment when the recollection was more vague. And what we found is a difference in the LPC with more vivid recollection, more positive than vague recollections. This paper also reported similar results as well. Vilberg and Rugg, about the same time, had people study items for 1 second or 6 seconds, and they made RK and N judgments, so remember, no new judgments, and they did both ERP and in one study fMRI. What they found is if you studied the item longer, you had a greater ERP LPC than if you only studied it for 1 second. The idea being that if you had a longer exposure, you had greater opportunity for recollection than if you only studied it for 1 second. So these studies do link the LPC with vividness. So to give a little bit of a summary here, the hippocampus is necessary, but it's not sufficient to elicit the LPC. The LPC might capture activation of the left parietal cortex, and you can look at that Vilberg and Rugg study for some evidence of that, as well as the Ali et al. Study that found patients with damage to the parietal cortex and did not have the LPC. This left parietal activation is probably downstream from the hippocampus, meaning the hippocampus has input to the parietal cortex, and it's related to the vividness of the recollection, maybe even connected to attention and working memory. You can take a look at this paper too for that connection with working memory. And what might be happening here is re-experiencing the memory, or this so-called mental time travel might be happening here and being marked by the LPC. So if you want to read a little bit more, McLeod and Donaldson challenged the association with the LPC and recollection. So take a look at that paper as a critical review. And Bergstrom has a number of papers that sort of showed that this recollection can be voluntarily controlled, which is a pretty interesting finding. Thanks for watching.